Hey everyone, notes 3.6 are on partial variation. So this is related to the direct variation that we did in notes 3.5. And there are two conditions that are necessary in order for something to have partial variation. So two things have to happen. The rate of change has to be constant and the initial value is not zero. So with direct variation, the rate of change is constant still. So this is true for direct variation, but the initial value is zero for direct variation. And so that's the difference between direct and partial variation. So a graphical representation of a partial variation will look as follows. So we would just have our x and our y values here. We've got 0 here. And this time it would start at a number other than 0. So it is no longer starting at 0, 0. It's starting at a new value. So this right here is our initial value, as opposed to when we had direct variation where it would start at 0, 0 and then it would go up or down from there. We could also have a graph that looks like this right here where we have an initial value still and it goes down. Okay, that's still an example of a partial variation. For our numerical representation, we would have x and y right here. And when x is 0, y is any number other than 0. So this will just say not 0 right here. Any other number that we have would work. And we would also have to have a constant rate of change. So here it's going up by the same amount every single time. This is just an example of a numerical representation. As opposed to when we had direct variation, we had x and y. 0 for x corresponded always to 0 for y. Now for our algebraic representation, so let's say you join a gym, there's a $100 fee plus $30 extra that you have to pay every month. So right here, your cost would be equal to $100 plus a $30 per month payment that you have to do. Or you could also say $30 per month plus the additional $100. But this plus 100 that we have here and right here, these are considered your initial values. So these hundreds are initial values. Versus when you have direct variation, you join a gym, there's no initial fee and you're paying $50 per month. So your cost right here would be $50 per month. Notice how there's no additional plus 100 on either spot right here. It's just this $50 per month. So this right here is an example of, so this right here is showing you direct. And this one right here is partial because of that extra $100 that's being added on. Okay? So let's look at a couple examples of partial variation. So in our example here, it tells us that a rental car costs $50 to rent plus 20 cents for each kilometer it is driven, okay? So we want to figure out what is the dependent variable. We're comparing the cost to the distance in kilometers. And we know that the cost depends on how far we go. So because the cost depends on the number of kilometers that are driven, the cost is the dependent variable. And because the cost is the dependent variable, it's going to be our y variable. So here we're going to put cost right here for y. And then the other variable is our distance, which is measured in kilometers. And to know what that initial value is, our x value has to be 0. So when we go no kilometers, how much are you going to pay? You still have to pay $50, okay? And then it says that we want to go up to 1,000 kilometers. I'm not going to do this 1,000 times. I want 1,000 here. So maybe if I go up by 200s, I'll be able to fit in all of these values here. Okay, so if it's 20 cents per kilometer right here, then these 200 kilometers, I'm going to multiply it by 20 cents right here. So 200 times 20 cents, and I end up getting $40 for those 200 kilometers here. So it's an additional $40 for those 200 kilometers. So this will bring us to $90, okay? Now this is an extra 200 kilometers. So here I'm going to pay an extra $40. So I'll be at $130 right here. Here's an extra 200 kilometers. So here's an extra $40. So I'll be at $170. So the next one I would add 40 to it, so I'd get 210. And then the last one I would add 40 to it and I would get $250. Okay? Now we can use this information to create a graph for our table. So we know that at 0 kilometers, we're going to pay $50. So I will go to 0 kilometers right here, and I know that I'm going to pay $50. So I can put a point at $50. I know 200 kilometers will be $90. I know 400 kilometers will be $130. 600 kilometers would be $170. 800 kilometers would be $210. And 1,000 kilometers would be at $250. And we will draw a line through these dots to demonstrate what's happening here. Notice how this time it starts on a different point on the y-axis as opposed to starting at the origin like we had with partial variation. So now question D says to identify the rate of change. And if you notice here, it tells us the rate of change in the original problem. It's 20 cents for each kilometer. But also, we can also use the rise over the run to figure this out right here. So here we have the rise is $40 and the run is 200 kilometers. So when I divide $40 by 200 kilometers, I end up getting 0.20, which is 20 cents per kilometer. So this is our rate of change. Now we need to identify our initial value. So we can identify our initial value several different ways. We can look at the description and it tells us that it costs $50 to rent. So we know that initially we're going to pay $50. We also know from our chart because it tells us if you go 0 kilometers, you'll still pay $50. And we know it from our graph because our graph starts on the y-axis at $50. So our initial value is $50. And then question E says to write an equation to model the relationship. C is the cost and N is the number of kilometers. So we know that we have to pay, the cost is going to be equal to an initial $50 plus 20 cents for every kilometer. Or we could also say 20 cents per kilometer plus an additional 50. Doesn't matter which way we do it. They're saying the exact same thing. Okay? So question F says to determine the rental fee for 345 kilometers. So here we are told that N is the number of kilometers. So what we would do is write down our equation. And because N represents the number of kilometers and we're told it's 345 kilometers, we can replace that N with 345. So this would say C equals. So notice how I replace that N with 345, okay? So now I can go ahead and figure out what C is equal to. So the first thing I would need to do is identify what 0.20 times 345 is. And I get $69. So this right here, I'm going to write plus 69, but we also have $50 that needs to get brought down. And when I add those two numbers together, I end up getting $119. Let's see if that answer makes sense. So if you look here, we'll go to 345 on our graph right here, and we can see, yep, it's approximately $120, which is very close to $119. So this answer does make sense. So question G says to determine the number of kilometers driven for a cost of $220. So this time we're given the cost. The cost is $220. So I can replace that C with 220 right here. And I want to solve for N. So the first thing I do is I get rid of that 50 by subtracting it. This goes away. 220 minus 50 is 170. 170 is equal to 0.20 n. Then I can divide both sides by 0.20 or 0.2, it doesn't matter, to get this n alone. So I would end up getting n equals, when I divide 170 by 0.020, this is what we get, 850 kilometers. So here we can say n equals 850 kilometers. Let's see if this answer makes sense. So I would go to approximately 220 on my graph right here and see where that goes down to kilometers, and we end up getting about halfway between 800 and 900, so it would be 850 kilometers. Awesome. And that's it for this example. Let's take a look at this example here, because sometimes partial variation will have an increasing rate of change and sometimes it will have a decreasing rate of change. So here it says there is $500 in Holly's bank account. She takes out $50 from her account each month, but doesn't put any money back in. So what is the dependent variable? So in this example right here, the amount of money that she has in her account depends on how many months she takes money out of her account for. So the dependent variable is the amount of money, because it depends on the number of months, or her balance. Another word for the amount of money is her balance. So make a table of values for up to 6 months. So right here, we're going to say time in months and balance in dollars. And it's really important that we always put 0 here to see what our corresponding Y value will be at that point in time. And we know at the beginning of this situation, she had $500. Then after 1 month, her balance goes down by $50. So now she has $450. After 2 months, it went down by another $50. After the 3rd month, it went down by another $50. 4th month, another $50. This is what our chart will look like. So now we need to create a graph for our table. So we know that at 0 months that Holly had $500. Then after 1 month, she had $450. After 2 months, $400. After 3 months, $250. After 4 months, $300. 5 months, $250, and 6 months she was at $200. And this time when we draw our line, we're going to start it at 500 and we're going to go down like this right here. And we're actually not going to draw an arrow because eventually she's just going to get to a point where she just doesn't have any money anymore. So now we want to identify the rate of change. Well, we can find it from a lot of different places. The first place we can find it is right here when it tells us that she takes out $50 each month. So her rate of change is negative 50 because she takes it out per month. We can also find it right here by doing our rise over our run. So this is negative 50 every time. And this is +1 every time. So I could do the rise is negative 50, the run is 1, and when I divide those numbers, I get negative $50 per month. Another option that I have is I can do rise over run right here. So like let's say I start here and I end here. This went down right here from 450 to 300. So this went down by negative 150. And then this went over from 1 month to 4 months. So this went over by 3. So we can say it's negative 150 over 3, which is still negative $50 per month. So you have a lot of options for how to find that rate of change. Now, for identifying the initial value, same thing. We have a lot of options to figure that out. Our first option is it tells us that Holly originally had $500 in her bank account. We also know from our table that she started off with $500. And we also know that from our graph that she started off with $500. Again, a lot of different places where we can find these answers. So now write an equation to model this relationship. Well, let's call B her balance, and let's call M the number of months. So we can say her balance started off at $500 and it's going down by $50 every month. So we put a negative 50 here, okay? Or we could say she's going down by $50 every month, but she started with $500. Either one of these answers is perfectly fine for an equation. All right, question F. How much will Holly have in her account for 8 months? So B equals 500 minus 50M. And here, this 8 months right here represents the number of months. So we're going to put in that 8 for M. So I'm going to copy the equation down exactly how I see it, but I'm going to replace that M with an 8. And I'm going to go ahead and evaluate. So negative 50 times 8 is negative 400. So I get 500 minus 400, which is $100. So she has $100 left in her account after 8 months. Now let's look and see. After 8 months, is it really true that she has $100 left in her account? Absolutely. Even if I extend, and then the last question, how many months will have passed when Holly has $50 in her account? This time the 50 will go in for her balance. So I'm going to say 50 equals 500 minus 50M. So now I need to get rid of this 500, and because it's an invisible positive 500, I would subtract it. Whatever I do to one side, I do to the other side. So 50 minus 500 is negative 450. Bring down this negative 50 over here. Divide both sides by negative 50. And I end up getting 9, positive 9 equals m. So it would take 9 months. But let's double check that this is right. So we go to our graph right here, and we can see at $50 for our balance, it did actually take 9 months. And that's it for this video. If you have any questions, let me know. Otherwise, I will see you in class. Bye.